This conference will now be recorded.
So last class we're discussing about, what is exactly difference between RPC port and HTTP port, right? So RPC is nothing but remote procedure calling. So we have given some example on some accessbank.com. So how the internal communication is happened between manager and the respective departments. That is nothing but by using LAN, local area network, right? Same way within the Hadoop. So we're having some different process names in which we know already. So within this process names, what are the process names we're having? So if name node has to communicate to job tracker, or job tracker has to communicate to name node. So what is this communication? Is nothing but it is a completely RPC, nothing but remote procedure calling. Okay, so this thing we discussed here. And as an end user, right? So now if you want to know some services or some information related to Access Bank, so how we are connecting? So we are connecting by using a, they're going to provide some unique what we call unique number. So maybe some starting with 040 or something. So by using that respective number, we are going to get some services, right? Same way here also as a end user. So if you want to know some information about name node or maybe some job tracker, so here also we're having a concept called as HTTP ports. So we have defined these HTTP ports, which are the predefined ports. Okay. So let us summarize 2 points and then we can go for further. So the internal communication within the bank. Within the bank, that is by using LAN network. By using LAN network. Same way, the communication between Hadoop process names is nothing but RPC. Okay, between Hadoop process names is nothing but RPC, remote procedure calling. Okay, but as an end user of Access Bank, if we want to get some services, if we want to know some services related to bank, we are unable to utilize LAN network. For this, they are going to provide a predefined, a unique number to contact them. Same way, if we want to know information related to Hadoop process names. Okay, information related to Hadoop process names. As an end user, we can use HTTP port. We can use HTTP port. That's it. Okay. So these points yesterday we have discussed already with clear example as well, right? So after that, we discussed about some architecture. name node, sorry, secondary name node, and job tracker. Okay, here we're having some data node, task tracker, data node, task tracker. Here also, sorry, data node, task tracker. And each data node, it has to communicate to name node. Each data node, it has to communicate to name node. And each task tracker, it has to communicate to job tracker. Each task tracker, it has to communicate to job tracker, and second name node is going to communicate to name node. And after discussing about this architecture, we have summarized some important points, right? So let's discuss the points once again. And these process names is nothing but masters, and these process names is nothing but slaves. So nothing but here masters is nothing but slaves. Okay. So what is the first point here? Hadoop is a master's slave architecture. Hadoop is a master slave architecture. And what is the internal communication between these Hadoop process names? So that is nothing but RPC communication. Okay. And how can we know which data node is down or which data node is running? Okay, nothing but how can name node can know which data node is running and which data node is running or which data node is down, or these things, this information related to data node. Okay, so the thing here we're having a mechanism called as a heartbeat mechanism. Heartbeat mechanism, that is for every 3 seconds. Okay, nothing but for every 3 seconds each data node has to communicate to name node. Okay, but suppose if any single data node is not communicating with this name node, then name node is going to feel that so this data node is down. Okay, then nothing but what we are calling as an heartbeat mechanism, that is going to happen for every 3 seconds. Every 3 seconds data node has to communicate to name node, so that name node is going to know which data node is up and which data node is down. Simple. Okay, and next thing is data locality. Data locality, nothing but Hadoop by default follows data locality, that is wherever the data is there, wherever the data is there, there only it is going to execute. Okay, so for suppose within this machine we're having some 1 terabyte of data, means 1 terabyte of data is there, means within this machine only it is going to execute or it is going to process. So that concept yesterday we discussed, right? And finally we discussed about one important point. So name node, secondary name node, and job tracker should be in a different systems or machines in real time. Okay, so here whatever the name node and second name node job tracker, so these three process names, it should be in a different systems and high-end configurations as well. Okay, in real time. And one more thing is previously we discussed about second name node is not going to act as a process names, right? I mean, whatever the metadata in which you're having in name node, same copy it is going to present in second name node as well. Okay, but not for process backup. So if you observe here, okay, second name node is not communicating to either of these data nodes. Just it is going to communicate to only name node. Okay, then nothing but what is exactly process backup. Okay, so whatever the tasks which is done by name node, so all tasks which is not done by second name node here. So here if you observe, name node is doing some, it is communicating each and every data node, but it is not happen with secondary name node. So nothing but what is exactly process backup, just it is going to maintain name node, what are the metadata which is present in name node, same metadata copy it is going to maintain in secondary name node as well. That's it. Okay, these things we discussed here. Okay.
This conference will now be recorded.
So next concept is nothing but design of HDFS. So these points we discussed. Okay, just we are recalling, and here we're having some more two more new points here. Okay, uh, in terms of HDFS, let me discuss. So one is storing the large amount of data, or we can say that large files. Okay, so in the large amount of data, so which we know, so HDFS is mainly for storing the large amount of data, or we can say that large files. It can be structured, I mean irrespective of data. Okay, so that is nothing but which we discussed already: block size, replication factor, and last one is metadata. Okay, and next point is streaming data access. Streaming data access. So that is nothing but write once, read many. Okay, write once, read many. So here, write once, read many is nothing but, so best example is YouTube. Okay, if you observe YouTube, so as a users, as a end users, so we are utilizing Gmail, YouTube, and I mean some different uh, products of Google, right? So if you observe the YouTube, so we can upload a video, but that video can be seen by, I mean, n number of peoples or our itself n number of times. So only one time we are uploading that respective video, but we are seeing or we are watching n number of times. That is nothing but write once, read many. So here also HDFS, once if you store some file within the HDFS, okay, so we can read any number of times based upon your requirement or based upon your utilization. That is nothing but what is exactly streaming data access. Okay, and the last one is commodity hardware. Commodity hardware. So that is here inexpensive hardware. So here, so if you observe in the previous architecture, so I have mentioned this data node and task records. Okay, so these data node and task records, we can maintain this inexpensive hardware, just like that 500 GB and 4 GB RAM. That is sufficient. whenever if you're going with data node and task tracker. But so if you're going with a name node, second name node, job tracker, so compulsory we need to go with the high-end configuration systems, okay, which may not be failed at any point of time, okay, because if you go for any clustering architecture, definitely some system is going to fail at some point of time. But whenever if you're going with high-end configuration systems, so there is 99.9%, so there is no chance of failing that respective system. Okay, so they're nothing but commodity hardware, so which is majorly for data nodes and task trackers. So because within the data nodes only actual data we are storing. So whatever the so whenever if you are storing a single file within the HDFS, what Hadoop is doing, that file is going to divide into n number of blocks based upon the block size. These blocks we are storing in data nodes, nothing but a machines, where exactly physical data is present in the system. There is nothing but in Hadoop point of view calling as a data nodes. These data nodes and task tracker we can maintain with a commodity hardware, nothing but inexpensive hardware. Okay, because we are following it a replication factor as well. Okay, and drawbacks in HDFS. So one is low latency, data access is not there. Okay, and second one is multiple writes and arbitrary modifications are not allowed. Multiple writes and arbitrary modifications are not allowed. That is nothing but no updates. And last one is lots of small files is an issue. Yeah, lots of small files is an issue. So here, first of all, low latency data access is not there. What is exactly this one? Okay, low latency data access. Okay, so I think most of you have some knowledge on this SQL. Okay, so for suppose if you don't have, so we will discuss later. Select star from student where student ID is equal to some 200. Okay, select star from student where student ID is equal to 200. So let us assume that so we are going with MySQL database. Within the MySQL we're having a couple of databases, okay, and nothing but couple of schemas. Okay, so here we're having a database name that is nothing but a student DB. Within the student DB we're having a couple of tables, and one of the table is nothing but a student. Okay, and within the student, let's assume we're having some 10,000 records. Okay, out of this 10,000 records, just I am providing one condition here. So that is where student ID is equal to 200, where student ID is equal to 200. So now internally if you're going with a MySQL, how this background is going on, how background processing is going on is, so once if you enter this query, once if you click on the enter, okay, so now it will search each and every record. So we have assumed that so we're having some 10,000 records per student table, right? So each and every record it is going to check. So whenever it is finding some student ID is equal to 200, so it will retrieve that respective row. It will retrieve that specific row, whatever the condition we have defined. But here if you observe what is the main problem is, so it is not directly navigating to this 200th row. So it is checking each and every row. It is checking first row, second row, third row, fourth row. Each and every it is checking, and finally it is navigating to 200th row. Okay, but as a end user, if you observe, if you if you execute this query, so you may get the result within the fraction of seconds, but it is not, it will not be happen with real-time scenarios here. So within the MySQL, if you're having some 1 million records means, so if you observe the, if you file a query like this, so it will take minimum 5 to 10 minutes of time to retrieve a single record. So why it is taking huge time? So because the reason is, so it is having, it is checking each and every record. There is nothing but we're having only file level indexing. Okay, we don't have a content level indexing mechanism in our whatever the database which we are having. Okay, this is nothing but what is exactly file level indexing. Okay, so but here this limitation, what are the limitation we are facing? This limitation we can solve it by using NoSQL databases. Okay, this limitation we can solve it by using a NoSQL databases. So here, what is a major advantage of NoSQL databases is, so whenever if you're query, if you're query, if you're executing a query like this in this NoSQL databases, it will not check each and every row. It will directly navigate into the whatever the condition we have mentioned. So here I have mentioned 200th row. So simply it will navigate to 200th row. So it will not check each and every record or each and every row of that respective table. Okay, so here so that we can achieve performance and readability when compared to our SQL databases. Here we're having content level indexing is there. We don't have file level indexing. Okay, content level indexing is not there in our existing SQL databases. That is the reason it is going to affect the performance of the system, okay, or performance of the application. So in order to overcome these limitations, what are the limitations we're facing in HDFS? So we can we are having an alternative called as NoSQL databases. So that is in Hadoop point of view. Within the Hadoop, so we're having one ecosystem called as a HBase. Okay, so here you need to observe is within the HDFS we're having a drawbacks, but solution is also provided within the Hadoop only. So Hadoop is nothing but HDFS, MapReduce, Hive, HBase, Scoop, Flume. These ecosystems, what we're exactly calling as a complete, complete complete framework of Hadoop. Okay, or complete list of Hadoop, right? Here HBase is one of the ecosystem of Hadoop, but we are facing the drawback within the HDFS. So if you want to overcome this first drawback, low latency data access is not there, so we can achieve by using a HBase. Okay, nothing but we need to install the HBase so we can integrate with HDFS, so that that limitation is going to be solved. Here each and every limitation, whatever the limitation you're facing in HDFS, so each and every limitation we're having a solution within the Hadoop only. So that is the reason. So Hadoop framework can be learned by any of the software developers or software programming, software architects, or anything. So whatever the different roles in the software industry, anybody can learn. That is the reason. So if you are strong in programming, you can go with MapReduce. If you are strong in SQL, you can go with Hive. If you are strong in scripting, you can go with Pig. Okay, anybody can learn this Hadoop. Okay, because it is not written in a single language, so it is written in a multiple languages. Multiple languages means not Java, C, C++ like this. Okay, so in terms of scripting we can go with Pig, in terms of SQL we can go with Hive, in terms of programming we can go with MapReduce. So like this, what is exactly these differences here. Okay, so is this point is fine, all of you? First limitation, any doubts? Okay. So now here, one more thing is multiple writes and arbitrary modifications are not allowed. Means simple, no updates. Okay, no updates. So if you want to update a particular file, out of the file which you already stored in HDFS, that is not possible. Okay. So what is the reason? So for suppose if you are updating, what is the what is the exact problem we are facing? So that thing we can discuss here. Okay. So now assume that is nothing but HDFS file system. Okay. Now within this we're having multiple blocks. Okay. So assume that we're having some total, I think, 1,000 blocks. So this is nothing but B1, B2, and B3. Okay, so each block nothing but a 64 MB. Okay, for suppose here I'm adding here a 1 MB of file. Let's assume I'm adding around 1 MB of file for this respect to B1 block. Okay, how much MB I'm adding here? For this respect to block 1 MB. So it is already having a size with 64 MB. So once if it is 64 MB, right? What is going to happen? We are unable to add any other. We are unable to add any other. What we can say that we are unable to add any amount of data for that respect to particular block. So if it is already 64 MB means we are unable to add any MB. Whatever the size we're having, it can be a 1 MB or 100 MB. So this size we're unable to add for existing block. So this B1 we're unable to add even for B2, B3, all these respective blocks. Reason is it is already having a block size with 64 MB with enough amount of data. We are unable to add this new MB, new size. What are the size you're having? 1 MB of size, we're unable to add for this respect to either of these blocks, either B1, B2, B3, any of these respective blocks. Okay. But suppose even though if you are trying to adding forcefully, right? So it will add only at the end of these respective blocks. Means so it was unable to add for any of these blocks, either B1, B2, B3. So if we need to add this 1 MB of file, okay, in this entire this HDFS file system, so it will add only after this respective 1,000 blocks. Or even if you want to add it, so for suppose if you are doing some HDFS commands, right? So once if you are adding, so there is no chance of update for existing block. What are the blocks we are having? Just we can append this file at the end of this blocks. At the end of this 1,000 blocks. So here we're having only appending concept is there. We don't have the concept of update. So even though if you're trying to update, we need to update. We need to check the n number of blocks. So again, it's going to affect the performance. So that is the reason here we don't have the concept called as an arbitrary multiple writes and arbitrary modifications. So just here simply can say that we within the HDFS we don't have update operation. Okay, instead of update we're having we're having a concept called as an appending. So this 1 MB file is going to backend at end of this respective blocks. Okay, so we can say that if you're adding or removing data, n number of blocks has to be updated. Okay, it will dictate the performance. Hadoop supports only appends but not for updates. Okay, so let us summarize some points.